Yes, Assalamu alaikum students and hello everyone. In the previous lecture, I explained the linear time invariant causal system, LTI. We talk about linearity and causality. Now I will explain the last property, which is time invariance. The time invariance is a very important property. So what is the time invariance? We already know when the signal moving from one place to another, it will facing some errors such as noise or distortion or dispersion. In digital, we can know the type of these errors by shifting, like you see here. Okay. So if a system has the property that a shift in the input by n naught results in a shift in the output by n naught. So this signal has been shifted by n naught. N naught could be a specific number, 3, 4, 5. So the invariant says if there is a shifting in input part, the same shifting should be in the output part. So if we meet this feature in the system, we call it time inverted. So any shifting happening in input should be the same shifting in the output. That's because the input should be same the output without any change. Okay, let's take some example. Determine whether each of the following systems is time invariant. The first equation, y of n equal x to the power of 2 of n. So this is the solution for A. Let me explain this solution. So this equation is used to process a specific signal. Is this equation correct or no? Is it time invariant or not? So how to know whether it is time invariant? If there is a shifting in input part, the same shifting should be in the output part. So the first step here is to number each equation. Y of 1 equal x to the power of 2 of n. It become y 1 of n equal x 1 to the power of 2 of n. As you see here, the first equation, it's become y 1 of n to equal x 1 to the power of 2 of n. So this will be the first equation. Same the given, it's same like the given equation in the question, but we number it with 1. So next step, we will assume that there is second input, which is x2 of n. X2 of n equal x1 of n minus n. So it's the same as the first input, but shifted by the n naught. The n naught is a specific number, as I mentioned before. It could be 3, 5, 2, etc. So any number. This is assumption. So x2 of n equal x1 of n minus n. This is a fixed step that we need to write it. We assume that we have another input. this second input, it's same the first input, but shifted by n naught. Okay. The next step, third step, since I have a second input, x2 of n, I must have a second output. Logically, if I have input, must be output. So the second output, which is y2 of n, will be equal what? Y2 of n equal x2 to the power of 2 of n. It's same the first input because it's same equation. So x to the power of 2 of n means the first equation here, we have first equation y1, we have x1 to the power of 2 of n, and now we have second equation. Also, y2 of n equal x2 to the power of 2 of n. But the x2 of n, if we refer to the previous equation, it actually x1 of n minus n naught. So we said it also equal x1 to the power of 2 of n minus n naught. That's mean the x2 to the power of 2 of n, which is come from this equation, we make a shifting by n naught, n minus n naught. That the y2 of n become x2 to the power of 2 of n, and also it will be equal x1 to the power of 2 of n minus n naught. So now I have first output and second output. I have two equations. Okay. Now, if the first equation or the first output, if we do shifting by n naught, look what we have now. We have second output or second equation that has been shifted by n naught. Okay. Now I need to check the first equation. Need to check the first equation if we also do a shifting by n naught. So y one of n minus n naught. So after this shifting, we need to check is will be equal to the second equation or not after we do the shifting here. So means y1 of n minus n naught, okay, which is this. All this equation will be shifted by n naught. So no any problems. It is will be x1 with y1 to the power of 2 of n, all this equation shifted by n minus n naught. So we did shifting by n naught for the whole equation. Look what the difference here. Where we have n, it become n minus n naught. But what we did here, what we did in this equation, we will say all the equation minus n naught. So all x1 to the power of 2 of n the whole minus n naught. Then we get this equation. Y 1 of n minus n naught equal x 1 to the power of 2 of n minus n naught. So we can conclude here that the second equation y2 of n, it exactly same to the first equation if we did shifting by n naught. Look here, x1 to the power of 2 of n minus n naught. And here same, x1 to the power of 2 of n minus n naught. Look to this equation. We need to check whether it's time invariant or no. So let's follow same previous steps. Okay. The first step, need to number each equation. So first equation, it would become y1 of n equal x1 of 2n minus 3. This will be the first equation. Same the given equation in the question, but we number it with 1. Okay. Next step, we will create new input, which is x2 of n equal x1 of n minus n. So we create a new input, which is x2 of n. And this input is fixed in all equation. Okay, which is x1 of n minus n naught. So this same equation in the previous question, it's fixed. Okay. Now, the third step, since I have a second input, x2 of n, I must have second output, y y2 of n. Okay, so y2 of n equal what? It's equal x2 of the same original equation, because the second output, it's same the first output, means y2 of n will be equal x x2 of 2n minus 3. It's exactly same y2 of n. So x2 of n equal, sorry, y2 of n equal x2. Okay, this is x2. So where's the x2? Here. This is our x2. Equal what? x2 equal what? Equal x1 of n minus n naught. So it would be also x2, it would be also equal x1 of 2n minus n naught minus 3. That's mean x2 of n, it's the x1 of n minus n naught. So when we execute it for this equation, okay, the 2n will, look here, look to this equation. The 2n will replace with n. The 2n will replace with n. So 2n minus n naught minus 3. That's for y2 of n. Now I have y1 of n. y1 of n and y2 of n. Okay. Now we assume that y1 of n will be shifted by n naught. So y1 so y1 will be assumed y1 will be shifted by n naught. So y1 n minus n naught will be equal what? It will be equal all this equation minus n naught. Okay, so all this equation will be shifted by n naught. So we get x1 of 2n minus 3. All this equation will be shifted by n. Then we enter the n naught inside the equation and become y1 of n minus n naught equal x1 of 2n minus 3 minus n naught. Okay, now is this equation is same like this equation? Yes, it's same. So the system is time invariant. Some student will ask, is it okay if here 2n minus n naught minus 3 and here 2n minus 3 minus n naught? Not same sequence. Yes, it's okay. Let's say n naught is 2, for example. So minus 2 minus 3 equal minus 5. And here minus 3 minus 2 also equal minus 5. So same equation. So now we can conclude y 2 of n, y2 of n equal y1 of n minus n naught. Okay. Therefore, the system is time invariant. So two simple steps. Okay. First, we number the given equation with 1. The second equation fixed for all questions. Next, since we have x2, we should have since we have x2, we should have y2. Since we have x2, second input, we should have second output. So the y2 is exactly same the original equation, but after n, we minus n naught, then the rest, which is minus 3. So n2 minus n naught, then minus 3. Okay. Then y1 of n minus n naught. We do shifting for the input. So y1 of n minus n naught, all this equation, okay, minus n. So after we do the shifting for all this equation, we do the shifting by n naught, we will compare whether y2 of n is equal with y1 of n minus n naught after shifting. If yes, so the time invariant. This is the time invariant. So this is the time invariant idea here, that the signal definitely 100% will facing some errors, such as noise or distortion or dispersion or interference or even jamming. That's why we will do shifting on that signal. So the signal which got shifting in input, it should be same the output. Not necessary to do also shifting in the output part. I mean, after we do shifting for the input, the result of this equation should be equal the output equation. So that we keep the signal that enters the input, it's the same one that output. Okay. So this is the end of this lecture. This lecture is the continuation of the previous lecture. So here I explain the signal and the system properties. that we need to use in digital signal processing, so that the system should be additive, should be homogeneous, should be also linearity. And the signal should be causality and time invariant. That's all for today. Thank you and have a nice day.